Hello everyone. Let us do the first numerical problem in regression. Okay, the question here is formulate the two regression equations for the following data. They give us marks in statistics, which is considered as variable x, and marks in mathematics, which is considered as variable y. Some 5 pairs of data is given. Also find the expected value of y if x is equal to 50 and the expected value of x if y equal to 25. And then find the correlation coefficient between x and y using regression coefficients. Now, let's proceed first forming the regression equations, both the regression equations. So, we know one equation is x on y, another one is y on x. So, let y equal to a plus bx be the, we'll write that, let y equal to a plus bx be the regression equation y on x. We had already seen then by method of least squares, the normal equations are we had seen those normal equations in our previous videos. If you haven't watched those, please watch those before coming to this. The normal equations are summation y equal to n times a plus b summation x. We'll consider this as, let me consider this as equation 1, this as equation 2, and then the second normal equation will be summation xy equal to a summation x plus b summation x square. Consider this as equation 3. So from this we understand that we need summation y, we need summation x, we also need summation of x into y, we also need summation of x square. So first now let us write the other one also. So together we'll make one single table. For that reason I am writing the other regression equation what we are planning to form, which is x on y. So let x is equal to c plus dy. Let me call this as equation 4, be the regression equation x on y. Then by method of least squares, the normal equations are first one, summation x equal to n times c plus d summation y. So this will be our fifth equation. Then summation xy equal to c summation y plus d summation y square. This will be our sixth equation. So from this, all the other things are already there in this, means summation x is here also, summation y is here also, xy is here also. Only thing which is extra is some y square. So based on this, let us create the table. The table is like this. I just wrote here x values, y values, whatever was given in the question. Then in this fourth column, I multiplied this x into y, means 40 into 30, like that. All the values I wrote, and then I wrote the sum of that also. So in this column, I found this x square. So 40 square is 1600, 30 square 900, like that. Then some y square. That means y, this particular thing, the square, means 30 the square, 40 the square, like that. And that summation is also being written there. Now let us go back to our second equation. Here it is. Sum y. From second equation, I will say summation y. Summation y is 170 is equal to n times, n is 5 because number of pairs of data is 5, plus b summation x. Summation x is 185. So I'll write plus 185 times b. This is our second equation. Then third equation is sum xy, which is 6312, is equal to a summation x. Summation x is 185. So 185 times a. Then b sum x square means 6983 times b. Now we need to solve the second and third equation. If we notice this 5, if I multiply this 5 by, let's say, I'll just find out what is 185 by 5. So 185 by 5, I'm getting 37. That means if I multiply second equation by 37, we can get, instead of 5, we can get that 185. So that subsequently I can eliminate a. So now let us do 37 into 170. We get 6290 is equal to 185 times a plus 185 into 37. We get 6845 times b. Let us call this as equation, already we wrote till 6, so I will call this as equation 7. Now, let us subtract third equation minus seventh equation. Means I'm subtracting this and this. So 6312 minus 6290. We get 22. And then this 185A, 185A gets cancelled. Then 6983 minus 6845. We get 138 times b, which means our b will be 22 by 138, which is 0.594 something. So I will just round it off to 0.6. Is there something wrong? Just a minute. It's total. Nine plus 4, 13, 1, 1 plus 4, 5, 5 plus 2, 7, 7 plus 6, 13. I think here I made a mistake. This should be, I'm sorry, this should be 6933, not 83. So I will correct it here. Let me write that as 3. So if we subtract 6933 minus 6845, I get 88. I'm sorry. It is, instead of 138, it should be 88. So let me write the correct data. 88. So we get 0.25 as the b value. Right. So now that we got b value, let me substitute this in equation 2. me write second equation. What is second equation? 170 equal to 5 times A, then plus 185 times 0.25, which means 170 equal to 5A plus, what is this, 185 into 0.25? 185 into 0.25, we get 46.25, which means 5A equal to 170 minus 46.25. What do we get? We get 123.75, means our A will be 123.75 divided by 5. So if we get a 24.75. So therefore the y on x equation, therefore the regression equation y on x is y equal to a, that is 24.75, plus b times, what is b? 0.25, 0.25 times x. So that will be our y on x equation. Now same way, let us find out x on y equation. So let us go back. Here we have fifth equation. Fifth equation is what? It is sum x is 185 equal to n times c, then plus n times c, yeah, plus some y, that is 170 times t. I should write 170 times t. And then sixth equation is sum xy, which is 6312 equal to sum y times c, means 170 times c plus second one sum y, which is 170 times c, I already wrote, plus y square. Y square is 5862 times t. 5862 times t. 5862 times t. Right. Now let us check what is 170 by 5. 170 divided by 5. Why I am choosing this? Because here I am having 170 and here I am having coefficient as 5. I am just trying to find out what is the this thing, how much it goes with. So 5 into 34 will give me 170. So what I am going to do now is I am going to multiply this fifth equation by 34 to get what? 34 into 185. We get the 6290 is equal to 170 times c plus 170 into 34. So it is 5780 times t. Let me call this as equation. I think we already wrote till 7th equation. I'll call this now as 8th equation. Now let's subtract what do you call 6th equation minus 8th equation. Why I am doing that? Because I can eliminate this C, 170C and 170C. So that is 6312 minus 6290. We get 22 is equal to 5862 minus 5780. We get 82. So 82 times D, which means our D value is 22 by 82. So 22 by 82. We get 0.27. That is our D value. So once we have D value, we can find out the other one, that is C, by using any of the equation. I will use fifth equation. 185 is equal to 5 times C plus 170 times 0.27, which is 5C plus 0.27 into 170, 45.9, which means 185 minus 45.9 equal to 5C. We get what? 139.1, which means our C will be 27.82. Right. So now what will be our regression equation x on y? Hence, regression equation, let me just put a box here. Regression equation x on y is x equal to c plus dy. Right. So we formed both the regression equations x on y and y on x. That is the first part of the question. Next is find the expected value of y if x is equal to 50. Means x is known, you have to find y. So I will have to use this equation because so that I can substitute x value here to find out what is y. So we have, let me say this is second part of the question. If x is equal to 50, to find y. What is y? We will write that equation, which is 24.75, then plus 0.25 times x, which will be 24.75 plus 0.25 times 50. So let's calculate that. 0.25 into 50 plus 24.75 means our y value becomes then 37.25. Then another part of the question is, what is the expected value of x if y is equal to 25? So if y equal to 25, to find x. So for that we will use x on y equation. X on y equation is x is equal to 27.82 plus 0.27 times y, which means 27.82 plus 0.27 times 25. So let us calculate that. 0.27 into 25 plus 27.82. So we get 34.57 as our x value. Means if y is 25, then x is 34.57, and if x is 50, then y is 37.5. So we got both the estimated values or expected values. Now let's move on to the last part of the question to find out correlation coefficient, that is R, given using the regression coefficients. So we know that is plus or minus bxy into byx. So here, when we come back to this, from this I can say this 0.27 is our bxy. Okay, and then going back to the previous equation, from this I can say our byx is 0.25. both the regression coefficients are positive. Both the regression coefficients are positive. So our correlation also should be positive. Since Byx and Bxy are greater than 0, R also should be greater than 0, positive. So I will write square root of what is Bxy? Bxy we identified as 0.27 and that one is 0.25. So what will be this? Let's multiply 0.27 into 0.25. The result I have to take a square root. It is working out to 0.26. So that's the correlation coefficient, which is obtained using the regression coefficients. I think we solved all the three questions. First question is to formulate the regression equations. We did it. Then we found the value of y given value of for a given value of x. Then we found value of x for a given value of y. Then we also found correlation coefficient between both these variables, and that too using regression coefficients. Yeah, this is the solution for this problem. And in case if you find this video to be useful, I request you to please like, share it with your friends, and also subscribe to my channel. Thank you.